Alright friends, welcome back. In this video I'd like to go ahead and cover section 2.1, and we're going to take it first day for this. So starting in chapter 2 here, I'll be honest, this is going to be a video that I'm going to try my best to keep relatively short because we are going to be talking about something in this video that you've probably talked about in a fair few algebra classes before, and that is linear equations. Okay, so we're going to have a brief discussion about what slope is and how to calculate it. We're going to have some discussion about how we can find the equations of lines and then use those to solve various problems here, and then also compare lines and tell whether they're parallel and perpendicular. So if you're looking for a more in-depth video covering these topics, I might encourage you to do some YouTubing. But again, these are topics that you should have been focusing on in your previous couple of algebra classes, so these should be topics that I would expect you guys to be at least a little bit familiar with at this point. So just to kind of go through it really quickly, right? When we talk about linear equations, obviously when we graph them, it creates a line. That's why we call them linear. And to describe that line, we can go ahead and have a conversation about the steepness of a line. In other words, the slope of the line, right? So the idea is that this is a number, that the larger the number, the steeper your line, okay? And the way that we characterize that, of course, is by the stair pattern, where we typically talk about a certain amount of units that you are going horizontally, or the run, versus a certain amount of units that you're going vertically, which is the rise. And so you can kind of see why I call that the stair pattern there, is because when you draw that out, it kind of looks like a series of steps. So to calculate the slope of a line, you basically just need the coordinates of 2 points. So say like x1, y1, x2, y2. And then the way that you would calculate your slope is in this way right here, where the way you calculate your rise is you do the subtraction of your 2 y coordinates, and the way you do your run is the subtraction of your 2 x coordinates. And so this triangle-looking symbol right here, that's actually a capital Greek letter D. It's called delta, and that's just a symbol that just stands for the change in. So when you subtract the two quantities, you're finding the change in those two quantities. So that's how we always classically find our slopes. You can go ahead and write the equation of a line by writing it in this slope-intercept form, and of course we call it that because if you look at the equation of a line, it has mx plus b. Playing the role of m is your slope, that's your steepness, your stair pattern, and then playing the role of b is your starting point, that's your y-intercept, and so that always is going to correspond to a point with coordinates. 0 is the x-coordinate, and then whatever the number b is as your y-coordinate, okay? So again, just some more review there. When you take a look at two lines at once, if they are parallel, then that's going to always mean that they have equal slopes. Their rise and their run are exactly identical. If you have perpendicular lines, then we always characterize those slopes as being opposite reciprocals of each other. You might have had a previous math teacher that called them negative reciprocals. I'm not a big fan of calling that negative reciprocals because it kind of gets across that your result is always going to be negative. And the idea is that we just want to have this idea of more of the opposite. So opposite in terms of sign, right? One of your slopes is positive while the other is negative. And they're also reciprocals of each other, right? So if you look at them as a fraction and you flip one of them upside down, you're going to be able to get the other one. Okay, so opposite reciprocals for perpendicular slopes. Remember Hoy and Vux for horizontal and vertical lines. Remember that Hoy, the O in Hoy is really the number 0, just to stand for the fact that any horizontal line has a slope of 0. The U in Vux stands for undefined, meaning that the slope of a vertical line is always going to be undefined. It's not even something that we associate with being a number. Okay, any sort of horizontal line, the Y in Hoy stands for the fact that all equations that are of horizontal lines look like Y equals some sort of number. All equations of vertical lines look like x equals some number, so we're going to see that here later in the video. And so what I'd like to do now is go ahead and do some calculations of slopes here. And again, we're going to make these go super fast because we want to go ahead and do the difference of the y's over the difference of the x's. And the order that you subtract them is not so important as long as you preserve the same order in the numerator and in the denominator. So you'll see that the way I wrote this down was the second minus the first. You could totally do the first minus the second. You just have to keep the order the same when you do your x's and your y's. Okay, so setting this calculation up here real quickly, your second y is negative 4 minus your first y is negative 5. When you do slope calculations, there's a lot of potential for you to have to subtract a negative. Just remember that that's a plus sign. It's going to give you negative 1 on the top. And then the second x is negative 7. The first x is 3. Subtract those, you're going to get 10. And I always want you guys to go ahead and make sure that you leave your slopes as fractions. So that's going to be negative 1 over 10. So that means for every 1 unit you might fall, you would run 10. So fall 1, run 10. And so that gives you a nice little stair pattern for the line there. Okay, here's the next example. We're going to do the exact same thing. We're just going to subtract the y's in the top, subtract the x's in the bottom in the same order. So negative 7 minus negative 7, that's going to give you 0 on top. And then on bottom, you're going to have negative 4 minus 3. It's going to give you negative 7. Okay, now 0 divided by any number besides 0 is always going to equal 0 itself. Okay, so if you conclude that you have a slope that is equal to 0, then what you can automatically conclude is that this is going to be a horizontal line. Because remember that the idea with slope is that the larger your slope, the steeper your line. Well, if you have a slope of 0, then that means you don't have any steepness. You have 0 steepness, so you're a flat line. Okay. Here in the next example, same thing. We're just going to do the exact same thing as before. So the second y is -8 minus the first y, which is +3. It's going to give you -11 on top. And then for the run, you're going to calculate your second x minus your first x, and we see here that that ends up being 0. And here is that situation where we're saying -11 divided by 0, and we know that we can never divide by 0, so that means that your slope is going to be undefined in this way, which means, of course, that you're going to be working with a vertical line, because all vertical lines have undefined slope. And then finally, in this last one with the fractions, we could just use a calculator to evaluate these fractions, but it would be the exact same thing. So second y minus the first y, it's going to give you a +3/2 if you were to do that, either mentally or in the calculator. And then in the bottom, we have a 1/4 minus 1/2. It's going to give you a -1/4. Okay? And if you were to go ahead and figure this out, right, by hand, this would be multiplying by the reciprocal when you divide by a fraction, right? So that's going to be multiplied times 4/1, and if you do the operations on that, what you should end up there with is -6. So being able to calculate a slope correctly and also being able to interpret it would be skills that I expect you guys to be able to have here in college algebra after seeing this in the past couple of algebra classes you've had. Okay? Here in these next couple of examples are going to give us a lot of different equations for lines. What we need to do is find the slope and the y-intercept. So the way that we're going to do that is we're going to solve for y in every single one of these equations, and then we're going to pick out what's playing the role of m and what's playing the role of b. So pretty easy to do here in this first example. Playing the role of m is just going to be 2. Playing the role of b is going to be 3. So that's pretty easy to point out. You might have one like number 6 where it's not y that's solved for, it's x. So for that reason, you just need to go through and do your usual inverse operations to get y by itself here, which I'll just demonstrate here really quickly. Okay, so again, this is all stuff that I would expect you guys to have a pretty good idea of how to do already without me having to take you through everything necessarily because you've been doing it for so long. But yeah, here I think playing the role of m pretty obviously is going to be 1/4. Playing the role of b is going to be 1/2. You might have an equation that looks like this in number 7, so it just has a y in it without an x, but that's no problem because if we divide both sides by 2, we see here that this is going to end up being y is equal to 2, and of course that is a horizontal line, and so the slope of any horizontal line is always going to be 0, and the y-intercept for any horizontal line is just going to be whatever that number is that is equal to y here, so that's going to be 2. A way to see that would be to rewrite this as y is equal to 0x plus 2, and then pick out your m and your b. In one like number 8, there's no y, so we'll go ahead and solve for x here. So -4 from both sides. This is going to give you -x is equal to -1, and then divide both sides by -1. And then we see here that x by itself isolated is simply just equal to 1, in which case we recognize that as the equation of a vertical line, one of those vuxes. And so the slope is always going to be undefined for a vertical line. And if you think about a vertical line, it's not even going to have a y-intercept, okay? So it's not going to pass through the y-axis because the y-axis is itself a vertical line. So for this, I'll just go ahead and say none. For the next equation down, this is an equation written what you call the standard form of a linear equation. It has its good uses for being able to do various things, but we need to be able to figure out what the slope is, which again means we need to solve this for y. So I'll do that by subtracting the 2x from both sides. That's going to give you 3y is equal to -2x plus 6, and then divide everything by 3. Again, our goal being to isolate y in this equation. So y is equal to -2/3 x plus 2, and I think pretty obviously there playing the role of m is going to be -2/3. Again, just comparing that to mx plus b, playing the role of b is 2. Next one over, same thing. We're going to solve for y, so subtract the 1/2 x over. And then we're going to have -1/4 y is equal to -1/2 x plus 12. And then in order to get that y by itself, one easy thing that you could do is multiply everything by -4. Okay, and the reason that you're doing that is because you're trying to get the number in front of y to be a 1, and so -4 is the number you would multiply times the -1/4 that's in front of y in order to make that a 1. Okay, so that's just going to mean I'm going to distribute a -4 to everything. So when I do that, I'm going to end up getting +2x minus 3, in which case you can go ahead and see here that playing the role of your slope is 2, and playing the role of your y-intercept is going to be -3. Okay, so the moral of the story there is that if they give you all sorts of different equations that you need to find the slope and the y-intercept for, you have to solve it for y and then compare it to mx plus b to figure out what the slope and the y-intercept is. Okay, I'm going to go ahead and skip down here to these examples here. So are the following lines parallel, perpendicular, or neither? Remember that in order to figure this out, we need to look at their slopes. If they have the same slope, they're going to be parallel. If they're opposite reciprocal slopes of each other, they're going to be perpendicular. And so in order to figure out what their slopes are, we're going to do the exact same thing. We're going to make sure every single equation looks like y equals mx plus b, and then compare the m's. So it looks like that first one is already ready to go. The slope of this line is a 2, playing the role of m. In the second equation, we're just going to need to go ahead and quickly divide everything by a 4, and rewrite this equation as y is equal to 2x plus 1, in which case we can see that the slope of that line is also 2. So because both slopes of both lines are the same number, 2, we would conclude that these lines are parallel to each other. Okay? Here in the next example, we have two equations that are written in more of a standard form here, so I'm just going to go ahead and rewrite this equation over here, solve it for y real quick, and then find its slope, right? So we can, again, go ahead and do this by doing the exact same steps as what we did for the previous problems here. 3y is equal to -2x plus 7, and then divide everything by 3. Divide by 3, divide by 3, divide by 3. So y is going to be equal to a -2/3 x plus 7 over 3. Okay, in which case we can go ahead and compare that to mx plus b and see that playing the role of m there, of course, is -2/3. Okay, in the next example, same thing. We're just going to go ahead and take care of adding this 3x to both sides of this equation, in which case we'd find here 2y is equal to 3x plus 5, and then after that, dividing everything by 2 to get y by itself. And we'd see here that y is equal to positive 3 over 2x plus 5 over 2. Okay, and again, we just need to figure out what the slope is because we need to be able to compare these two slopes and see here that one of them is positive while the other is negative. And also, if you flip one upside down, you get the other. So these are, of course, opposite reciprocals of each other, and that is going to mean that we can conclude that these are perpendicular lines. So being able to figure out what the slopes are enough to compare them to each other and figure out if they're the same for parallel or opposite reciprocals for perpendicular, very, very important to be able to do. So again, a lot of information in this video that you have seen a lot of times in your previous algebra courses. So to be very honest with you, this would be stuff that I would expect you to already know. So just doing a quick video of this today is, I think, pretty satisfactory. So if you guys have any questions whatsoever, as always, please feel free to let me know. But thank you very much for your attention, and I will speak to you in the next one.